Assalamualaikum warahmatullahi wabarakatuh. Welcome back. So we're going to continue with the part 2 of IIoT reference architecture. So in the part 1, we already see the control domain. So in here, we're going to look into the another 4 domain, which are operation domains, information domains, application domain, and business domain. So let's go to the operations domain. So what is the operational domain? Traditionally, we'll see that control system will interconnect and communicate with only system within their own environment. Like we see previously, it is just the device and also its own apps, right? With the advent of the industrial internet that has changed, now the IIS are communicating with other IIS on the other side of the globe through the internet. Okay, so by exchanging data and learning from each other. So all of this happen through the operational domain. The example that we can see is like optimizing a taxi company's operation by what we call by cost saving and lead to operational efficiencies and everything. So this one can be done by connecting to the other IIS. Okay, so this happen through the operational domain. Okay, so we can break through to the customers through this operational domain. So under operational domain, there are several elements or several functions that we have to know. They are provisioning and deployment, management, monitoring and prognostic, and also optimization. So let us see all of these functions. Now, the first one is provisioning and deployment. It consists a set of functions that require in order to configure onboard, register and track asset, and to deploy and retire asset from operation. Okay, so this one is like the easiest example that I can give to you is like our laptop. So sometimes we have to connect with the internet and everything. We can configure the line, and then we can register our line, and then we can track our asset, and we can also deploy or retire that asset from the operation through this provisioning and deployment. Okay, so this function must be able to provision and bring asset online remotely, securely, and at scale. So meaning that it is the function where it allow the computer or the devices that you have to be online remotely, securely, and at scale. Okay, so they must be able to communicate with them at the asset level as well as the fleet level, given the harsh, dynamic, and remote environment common in industrial context. So this operational domain supposed to be able to make the what we call the devices and all the system to be online remotely, securely. Although we know that in the industrial context, it is what we call there is a harsh and dynamic environment. Okay, so uh, it is important for this to happen. If not, then we are not able to connect with the other IIS. The second one is management. So what is the management function here? It consists set of functions that enable asset management center to issue a suite of management command to the control system, and from control system, it will give command to the what we call to the asset to respond to this command. Okay, so it meaning that it's going to be from management command to the control system and then to the asset. If not, then there is no connection between the command from the management to the control system and to the asset. Then the what we call the system is not functioning. Okay, because there is no connection in terms of the command and also the asset to take that response to that command. For this, many of the legacy dumb asset need to be retrofitted to have compute, storage, and connectivity capability. So, what does it mean by dumb asset? Is the asset that previously it is not able to do the computation, storage, and connectivity. It need to be changed to so that it has this capability to compute, storage, and connectivity capability. The next one is monitoring and diagnostic. This one consists of function that enable the detection and prediction of occurrence of problem. So meaning that the system will monitor and then make diagnostic and detect any occurrence of problem in the system, so that they can send the signal to the control system, so that action can be taken before we can what we call take action on this problem. It is responsible for real-time monitoring of asset key performance indicator, collecting, processing asset health data with intelligence, so that it can diagnose the real cause of the problem and then alter the abnormal condition and deviation, so that the system can still operate although with this problem. Okay, so if you remember about the IP mobility that we see previously, I can give example like, for example, there is a problem with the connection with IP1. So monitoring and diagnostic component will be able to detect, let's say there is a problem with IP1. Okay, so then we have to switch it to the IP2. So this is what happened in the operational domain, where it will monitor and make diagnostic on the problem. So and then it deviate or it find the solution to that problem, so that the system itself will not be disturbed. Okay, this set of functions should assist operation and maintenance personnel to reduce the response time between detecting and addressing a problem. So this is very crucial in the industry, where we don't want to spend more time to find the problem and to solve that problem. If let's say we will be able to do the monitoring in real time, and then we can deviate that problem so that the operation is not disturbed, then it is a much better option for the industry. Okay. The next one is prognostic. So what is prognostic? It is concept. It consists of the set of functions that serve as a predictive analytic engine of the IoT system. Uh, this one, uh, previously we see that it is detecting what the problem is. Prognostic, it is like it's predict what will be the possible problem that might happen in the future. Okay, so it relies on historical data of asset operation. So meaning that they will take what we call the record of downtime, the previous problem that being what we call being getting into the asset operation previously, and how is the performance of that asset, engineering and physical properties of asset, and modeling information. When all of this data is gathered together, they can predict what will be possible problem that might happen within like 1 month or set 2 months or something like that. So then they can identify this potential issue before they occur, and then provide recommendation on their mitigation. So meaning that uh, when we already identify what will be the potential issue, maybe we can tackle that issue before it happen. For example, we can do the preventive maintenance of that asset, so that when it can be prevented, it will not cause any downtime to the what we call to the line or to the industry as a whole. Okay. So the next one is optimization. It consists a set of functions that improve asset reliability and performance, reduce energy consumption, and increase availability and output, and correspond to how the assets are used. Okay, so since previously we have the prognostic where it can predict the problem and everything, so optimization, it will do the calculation and see how we can increase the performance of this asset, how we can reduce the energy consumption of that asset, and how we can increase the availability and output in correspond to how the asset is used. Okay, so this is how the optimization work in the operational domain. So it helps to ensure asset operating at their peak efficiency by identifying production losses and inefficiencies, and this procedure should be automated Okay, so everything is done automatically. It is not like we have to check and to have to do to run the optimization every time we want it to be. Okay, so it's supposed to be in real time and it's supposed to be automated. Okay, so that this one we can avoid potential inaccuracy and inconsistency in the asset and also in the operation as a whole. So for optimization, in order for us to get this optimization, there are several conditions that require to be reached. For example, the first one is automated data collection, validation, processing, and analytic. Okay, so for example, you have a line of a product that you create or you produce in the factory. So the data of the operation is supposed to be automatically collected. It's supposed to be automatically validated, and this data will be processed and come out with the what we call the graph or anything, so that is we can analyze what is the operation as a whole at one time. Okay, and the second one is its ability to capture and identify major system alarm, event, and issues such as power failure, system network failure, latency, packet loss, downtime, and non-responsive application. So this is another what we call a condition that's supposed to be happening. It's supposed to be done in this industry. So if it is not able to capture and identify all of these major system alarm and all these power failures and everything, so it is the system itself will not be functioning. Okay, so it's supposed to have this function where it able to identify the system. Okay, the problem is the system. The third one is the intelligence and capability to analyze and determine root cause for known problem. Okay, so as we see already in the previous element of features functions in the operational domain, this is one of the things that is very important, where the system that being created for this industry using the IIS supposed to have the intelligence and capability, so to analyze and determine the cause of the problem, so that we will be able to make steps so that we can solve the problem before it happen, or before it become a problem to that industry. The next domain is the information domain. Now let us look what is information domain. Suitable to the name of the domain, which is the information domain, the objective of this domain is to transform the operation data harvesting from the other domain. For example, predominantly the control domain itself, and also the vast array of the sensors. All of this data, we want to change it into information that readable by the user. Okay, so that we can subsequently use as a control feedback to stabilize or improve the process. Okay, so meaning that um, all the sensors and everything that are already working, we want to collect all this data, and then we want to analyze it so that it becomes some information that is beneficial to the user. Okay, however, in the information domain, the goal is not just to collect raw data, okay, not raw sensor data. The goal is to collect sensor data, and then we store, and then we process it so that it can be transformed from raw data to information, and then distilled into knowledge. Okay, transforming raw data into knowledge greatly enhance our ability to adapt and improve operation and business decision making, and optimizing the process function, which deliver great productivity, profit, and operational efficiency. So how does this function will help to what we call to improve operational and business decision making? Like we see previously, in the what we call operational domain, they will analyze and then see there is possibility of the what we call error or anything. So in this information domain, in the production line, you might see that how much is the product is being produced, and then how much is the product is going out, and how much is in the storage, how much is the one that what we call that produce and have error or something. So all of this data we can generate it into a graph or some information that readable by the user. Then the operation based on this data, we will be able to decide, oh, how much is the product that we want to produce more, and which product we want to reduce, and which one is having a very there are a lot of error in this product. So we can detect what are the problem and how to solve it. Okay, so then this one will optimize the process of the process as a whole, and then you can also improve the productivity and profit and operational efficiency. Okay, so under the information domain, we have two things that what we call two elements, which are data and analytics. Okay, now let us look the data in the information domain. Okay, so this data consists of the function where it ingesting sensors and operating state data from all domains. Okay, so meaning that it's collect all of the data from the sensors, from all the operation state. Okay, so this data and then will be what we call the data cleansing, filtering will done via the quality of data processing, so that you can get a quality from that data processing. So it will eliminate any duplication, any data is wrong, that or something that is not what we call related to what you want as a result to be seen, to be analyzed, so it will be clean. Okay, so the next one is synthetical transformation. For example, not all the data, like we learned previously, certain device might use different protocols and different languages. So in this data, it will transform the data into a format that normalize to everything, so that it will be easier to be understood or to be analyzed. Okay, so and the next one is also do the collaborating of data set, because the data might come from different type of sensor, right? So this one, the data will be collected and then will be transformed into the language that is readable, or into a format that is readable, and to get the graph or anything. Okay, and then it will collaborate and we'll see the interconnection between the data from sensor 1, sensor 2, sensor 3, or some different machine even. Okay, and then it also have the function for data persistent and storage, whether you want it to save it in batch, um, or it can be done automatically in real time. Okay, and then the last one is function for data distribution. After you did all the data analysis and everything, they're supposed to have a function where you can distribute that data. Okay, the second part for the information domain is analytics. So this one, it has the function for data modeling, analytics, and other advanced data processing, such as the rule engines. Okay, so once we already have all the data and everything from the data part, okay, so this data supposed to be going into data modeling and analytic, is supposed to be analyzed automatically. Okay, so the analytic function may be done in online streaming, so meaning in real time, or offline, which is the batch mode. So meaning that you collect all the information first and then you do the analysis in batches. Okay, so in the streaming mode, even an alert may be generated and fed into the function in the application domain. So this one, if let's say in streaming mode, when it is in real time, so analysis or alert will come if there is any problem or any what we call errors or anything that being detected, it can will be going into the application domains later. Okay, so in batch mode, the outcome of analysis may be provided to the business domain for planning or persisted as information for the other applications. So meaning that it is not going to have alert in real time. Okay, so you gather all of this information, you do the analysis, and then this analysis will be provided to the business domain so that they can use this data to make what we call decision in the future. What will be the next what we call uh, decision you want to make for the business? Okay, the data volume of the at the system level is in most IoT system will eventually exceed a threshold. Okay, because when the operation is done 24 hours, let's say, and you have like thousands of sensors and thousands of devices that using the system, of course, the data will exceed the what we call the limit that we able to be able to analyze the data. So here come the big data storage and analytic will be considered to be implementing in the function. Okay, so let's say when you first decide to set the factory and everything, you will be able to project already or how much the sensors that you're going to use and how much the data that will come in into the system to be what we call to be analyzed. So if let's say your data is very big, so here come the big data storage and analytic to be applied in your system. Now let us look into the application domain. So what is the application domain? So what is the application domain? The application domain represents the collection of functions implementing application logic that realize specific business functionality. Function in this domain apply logic, application logic, rules and model at coarse grain, high level for optimization in a global scope. They do not maintain low-level continuing operation as they are delegates to function in the control domain that must maintain local rules and model in the event of connectivity loss. Okay, requests to the control domain from the application domain are advisory so as not to violate safety, security, or other operational constraint. So the easier things that I can give example to you is this application domain. It apply what we call they have set certain logic and rules for that functions in the system to work separately and not crossing from each other and then causing any chaos or anything with the function. Okay, so this application domain will set that uh, this logic whether what will be the function for this one, and then it runs by its programmable function. And let's say this function number one, function number two, function number three. So all these three is not collide and make into something that is chaos into the system. Okay, so it allow this function one to run as function one, function two to run as function two, and function three to run as function three. Okay, so this is the easiest way how we can understand the application domain. The decomposition of the application domain, here we have API and UI and also logic and rules. Okay, so let's see what is logic and rules and also API and UI. For the application domain, it composed of two things, which are logic and rules and also API and UI. So let's see what is logic and rules. It comprises logic, which are the rules, model, engines, activity flows, and everything. Uh, Implementing specific functionality that is required for the use case under consideration. It is expected that there are great variation in this function in both its context and its construct among the use cases. Okay, so logic and rules are all the rules that logically apply to these functions inside the system, so that all of this system will follow this logic and rules and it will not collide with each other. So that each function will be able what we call to function, to work, to make the things work, okay, according to the functions that being already being what we call program. Okay, so the next one is APIs and UIs. You can I attach also the hyperlink to the description how what is API and what is UI. Okay, so we're going to see it generally in here. So what is a API and UI? It represents a set of functions that an application exposes its functionalities as APIs for other application to consume, or human user interface enabling human interaction with the application. So APIs is like what we call um, it is connection between, let's say we give the command, and then it will what we call send it to the control system, so that it will generate the result from what are the things that we want to get, and then come up with the result to us. Okay, for example, if let's say you want to order, you want to book a ticket of the train, you will put, let's say, the date, and then from where to where, and then the seats or anything, all the details that we want to put it inside there. That is like an order of that, what we call for that API. It will send to the what we call to the system. So then it will generate all the result based on the requirement that we give, like the comment that we give, and then it will come out with, okay, this is the available date. For that available date, this is the train number, this is the seat that you can book, and everything. So that is the API, where UI is the user interface, is the it enable a human interaction. It's like a design of the, for example, let's say a website. So there is a design, so that website, you it's the user interface. Okay, so where you can search, or you can what we call fill in the forms or anything on that website, or so that is the user interface. Now, here is the last domain, which is the business domain. Let us look into the business domain. So let's see what is the component under the business domain. Okay, so this business domain have function enable end-to-end operation of the industrial Internet of Things system by integrating them with traditional or new types of industrial Internet system, specific business function, including those supporting business process and procedural activity. Okay, so in here, what does it mean is, um, other than operational domains, all the what we call the functional domain, we also we need the functions for the business to be run. Okay, so something that out of the operation itself, in order to make sure that all the operations and also the functional domain to what we call to works smoothly, we need something, some function that help that function to run. Okay, so for example, this business function, for example, the enterprise resource planning, customer relationship management, product life cycle management, manufacturing execution system, human resource management, asset management, service life cycle management, billing and payment, work planning and scheduling system. So this one, this domain, this function does not involve directly in, let's say, the function of the operational of the factory, or in the operational of that industry, but it is required in order for us to manage the people. We want to manage the what we call the overall things outside of that circle of the production. Okay, so that's why the business domain is very important. Now, the last viewpoint that we're going to look into is the implementation viewpoint. Okay, so the implementation viewpoint concerned with the technical representation of an IoT system and the technology and system component that required implementing the activities and function prescribed by the usage and functional viewpoints. So An IoT system architecture and the choice of the technology used for its implementation all usually will be guided by the business viewpoint, because of course all the boss will be the one who will, what we call, come out with the result, whether to invest the money into applying some what we call, to implement something. Okay. Including cost and go-to-market time constraint, business strategy in respect to the targeted market, relevant regulation and compliance requirement, and planned evolution of the technology. The implementation must also meet the system requirement, of course. If it is not meet the system requirement, what we call, it is useless, right? So including those identified as key system characteristics that are common across activities and must be enforced globally as end-to-end properties of the IoT system. The implementation viewpoints therefore will describe certain points in the, what we call, in the business itself. Okay, the first one is the general architecture of the IoT system. For example, the structure and the distribution of the component, the topology by which they are interconnected. And then the technical description of its component, for example, the interface, the protocol, what are the behavior and other properties that you want to implement inside your system. And then an implementation map of the activities, like previously we have to identify in the previous viewpoints, we have to consider what will be the usage, right? So and then we create what are the activities that need to be done in order to realize the objective of the business. So in this implementation, they will map the activities and identify in the usage viewpoint to the functional component, and from functional component to the implementation component will see what kind of activities is supposed to be created for implementation. And then an implementation map for the key system characteristic also will be needed. So here is the summary for the IoT reference architecture. So we see there are 4 type of viewpoints, which are business viewpoint, usage viewpoint, functional viewpoint, and implementation viewpoint. So under functional viewpoint, it is divided into 5 domain, which are control, operations, information, application, and business domain. So to understand more on this IoT architecture, I put the video link over here. So you please look into the video where the information is described in a better words so that it is easier for you to understand. That's all for today. Thank you for listening. Assalamualaikum.